Hello, welcome back. We're going to start a new unit. It's weird to say because it's really only 3 sections and even just 2 lessons. So we're going to do 5.1 and 5.2 together, and then we're going to do 5.3. And this whole unit is just about using trig identities. A lot of which of these trig identities you already know. It's just now using them to verify different things. So we're going to use fundamental trig identities to verify identities, and I'll show you what that goes through. So 2 objectives: recognize and write the fundamental trigonometric identities. We have talked about these already, but it's just kind of putting everything into one place. And then we're going to verify trig identities, meaning we're going to be given a statement and we just want to verify that that statement is true. Okay, so we're going to go through and we're going to just put all of our identities here just in one spot. Okay, so our reciprocal identities, we already know this. More importantly, like we start with the lowers, like cosecant of x is 1 over sine of x. Right? Which means sine of x is 1 over cosecant of x. Secant of x is 1 over cosine of x. So cosine is 1 over secant. Cotangent is 1 over tangent of x. So then tangent would be 1 over cotangent. So again, those are not new identities. We know those already. Our quotient identities or our ratio identities, tangent is equal to sine of x over cosine of x. Again, we know that, right? That's not new. Cotangent is the reciprocal of tangent, so cotangent then would just be the opposite, right? Cosine of x over sine of x. Okay. So again, those are not new, right? We've written those down, we've used them. It's just nice having everything in one spot. Okay, so I'm going to scroll down a little bit. Now we're going to look at the Pythagorean identities. Sine squared plus cosine squared of x equals 1. Okay, so if I have sine squared of x, cosine Okay, so sine squared plus cosine squared equals 1. And then we've talked about this already, but there's 2 identities that can be derived by this by dividing by either sine squared or cosine squared. So when we do that, I'm going to write down the Pythagorean identity. So sine squared plus cosine squared equals 1. So let's just divide by sine squared first. So if I divide by sine squared, I have to divide everything by sine squared. Okay, so sine squared over sine squared is just 1, right? Cosine squared over sine squared is cotangent squared. And then 1 over sine squared is cosecant squared, just using those identities that we just wrote up above. So there is one of the identities that can be derived. The other one is if I take my Pythagorean identity again, and then this time if I divide by cosine squared. So I'm going to divide, remember if you divide one thing by it, you have to divide every single term by cosine squared. So sine squared over cosine squared is tangent squared. Cosine squared over cosine squared is 1. And 1 over cosine squared is secant squared. So that is the other identity that can be derived. And then you can adjust these however you need to, right? So for example, for the Pythagorean identity, if I subtract cosine squared of x to the other side, I get sine squared of x equals 1 minus cosine squared of x, right? Or if I subtract cosine or sine squared of x to the other side, I get this one. So, we can move around things within these identities, right? You can subtract something to the other side or whatever, however you need to get that to work for whatever the problem is. And then the last one are the even odd identities. So if we think back, the only two trig functions that were even were cosine and secant. So this would just get me, if I plug in a negative value, I would just get positive, okay? All the other ones, if I plug in a negative x, it will make the function negative. So all these other ones are odd functions, like so. So just kind of having these identities all in the same place is helpful because, these trig identities, they show relationships between trig functions. So let's kind of scroll down here. So we can switch things out using these trig identities to verify an identity. So in order to do that, basically we have a statement, right? Something equals something. And we want to show that one side is equivalent to the other. So typically a strategy that I tend to like to use is just leaving one side by itself, not touching it, and then just working on one side to try to get it to look like the other side. The thing that makes these hard is that I can't just tell you step one, do this, step two, do this, right? Every single problem is different because it depends on what you're given and it depends on what you're trying to accomplish. So here are some strategies. Again, they're not like steps, but they are strategies to help you kind of figure out ways to do this. And I will say that even myself, like now, and most people, they may start a strategy and find out that it leads nowhere and then have to start over. And that happens to me sometimes too, where I'm like, oh, I'm going to try to do this. And I like go through and then I'm like, oh, I'm stuck. I can't go anywhere. This wasn't the way that I was supposed to do it. So then I erase it and try something else. So don't get frustrated if that's happens to you, because it tends to, for some of these more difficult ones, it can be, a little bit overwhelming. So here's the strategies, right? First strategy, we should just know these basic identities that we just did on the front page so that they come to mind easily. So like I can look at something and be like, oh, well, I know that tangent is sine over cosine. Sometimes it's helpful to write all your expressions in terms of sine and cosine, just because those are kind of like the basic. Perform indicated algebraic operations such as multiplying, adding fractions, factoring. Make sure that you're having common denominators when adding or subtracting fractions. Is another strategy is replace an expression equal to 1 with a Pythagorean identity, the sine squared plus cosine squared. This step 5 is the step that I was saying, like work with each side of the equation independently. So don't try to like work at each side at the time. I usually leave one side as is and I only work on the other side. Multiplying a fraction by 1 can be really helpful. Remember that if you you can multiply by 1 in any form, right? So you can multiply by 1 as like sine squared x over sine squared x, or you can multiply by 1 in the form of, the example here was 1 minus cosine of theta 1 over 1 minus cosine of theta, right? You're just multiplying by 1. Stop and start over and try something new if you're not getting anywhere, and that's what I was talking about earlier. Okay, so we have quite a few examples here that we're going to go through, and if any of these don't make sense or you're getting stuck or whatever, just make sure that you reach out for help, okay? Okay, so here we go. For A, I want secant of x, cotangent of x to equal cosecant of x. So I want to verify that this is true. Okay, so the way that I do that is I'm going to work on the left side and I'm going to try to get the left side to look like the right side. So one strategy that I like to do if I can, is to rewrite everything in terms of sine and cosine. So secant is the same thing as 1 over cosine of x. And that's being multiplied by cotangent, which is cosine of x over sine of x. And then I just usually put the equal sign and just move it on down, okay? So here I get cosine of x over cosine of x sine of x. Well, the cosines can cancel, which leaves me 1 over sine of x. And 1 over sine of x is cosecant of x, which is what I was trying to get to. So I have verified that secant of x, cotangent of x equals cosecant of x. So that's basically what we're doing is we're working on one side and we want it to get to look like the other side. So that was a fairly simple one. These will get a little bit harder as we go. And I tried to do like an example of like one of each type that maybe you would see. Okay, so let's look at B. Cosine of theta times secant of theta over divided by cotangent of theta. So I'm going to kind of write this out all in terms of sine and cosine. So I have cosine of theta over 1 times secant of theta is 1 over cosine of theta. And then divided by, I'm going to write it like this. Cotangent of theta is cosine of theta over sine of theta. So hopefully that makes sense how I got that so far. Here, cosine of theta times 1 over cosine of theta times 1, the cosines just cancel, and I just get 1, right? 1 over 1. Divided by, oh, and remember how we divide fractions? We copy, dot, flip. So I sine of theta over cosine of theta. Well, 1 times sine of theta cosine of theta is just sine theta over cosine of theta. Oh, sorry. Wow. Yeah, no, that's right. I'm blanking out. Sine theta over cosine of theta. And then sine theta over cosine of theta is tangent of theta. And that's what I was trying to show. Now, that's not the only way to do this one. Okay? I could have also done this, where I could have also done cosine of theta over 1 times 1 over cosine of theta, because that's secant of theta. And I just keep it over a cotangent of theta. Well, this is 1, so that becomes 1 over cotangent of theta. And 1 over cotangent theta by rule is tangent. That's another way you could have done it. So a lot of these, there's not just one way. Okay, so hopefully we're feeling okay so far. I know I know these are not easy, and I'm not like trying to pretend like they're easy, okay? Oh, the lighting's starting to get weird on me. Okay. All right, here. I have cosine squared of x minus sine squared of x, and I want to show that this equals to 2 cosine squared of x minus 1. Okay, so I really want to get rid of the sign, right? I want to get rid of the sign, and I only want cosines. So I'm going to leave this cosine squared because I'm okay with having cosines in the problem. I'm not okay with having sines in the problem because I want just cosine. So I'm going to use my Pythagorean identity, right, which is sine squared plus cosine squared equals 1. So if I subtract the sine squared to the other side, I get that sine squared is equal to 1 minus cosine squared. Does that make sense? So then this is equal to 1 minus cosine squared x. So I wanted to get rid of sine squared, and because it's squared, that leads me to think of the Pythagorean identity. So I'm going to distribute. So I have cosine squared x minus 1 plus cosine squared x. And then if I combine my like terms, I have 2 cosine squared x's minus 1, which is what I was trying to show. So again, looking at this and saying, okay, I don't want sine squared anymore. So the sine squared is something that I'm going to have to get rid of. What identities do I have that involve a sine squared? And then that's what leads you to the Pythagorean identity. Okay, now we start getting into the big guns. Okay, so here I have cotangent squared of t over cosecant squared of t equals cosecant t minus sine of t. So the big clue here is because this is one term and this is 2 terms, I'm probably going to need to do something to both sides, and that's okay, all right? But the big thing is just work on one side at a time. So I'm going to start here, and I'm just going to see like what I can get rid of, if I can simplify it in any way, things like that. So the trick of getting it down into sines and cosines can be really helpful. So here, cotangent squared is cosine squared over sine squared. And that's over cosecant squared is 1 over, oh sorry, it's not cosecant squared, it's just cosecant. Cosecant is 1 over sine. I don't like writing a complex fraction like this, so how I typically would write it is cosine squared of t over sine squared of t divided by 1 over sine t. Okay, and then, because then I can see, oh, I need to copy dot flip, right? So I copy cosine squared of t over sine squared of t times 1 over, oops, sorry, I didn't take the reciprocal, sine of t over 1. So one of my sines can cancel. So I'm left with cosine squared of t over sine of t. Which kind of like at this point, like I don't know if I necessarily have anywhere else to go from here. Like I can break this down into tangent secant, cotangent secant, cosecant, but it's like doesn't really matter, right? Like I could say this is cotangent of t times cosine of t, but that doesn't really get me anywhere, and it's still only one term. I'm just going to leave it here. Let's see what happens. Okay, so now I'm going to have to do stuff on this side. Cosecant is 1 over sine minus sine of t over 1. In order to subtract, I need to get this to one term, right? Everything over here is just one term. So I have to subtract these fractions. Well, in order to subtract the fractions, I have to get a common denominator. So my common denominator is going to be sine of t. So I'm going to multiply by sine of t over sine of t, which gets me 1 over sine of t minus sine squared of t over sine of t. So then when I subtract this, I get 1 minus sine squared t over sine. Okay, I'm really close. Like these two look really similar. It's one term. They both have sine of t on the bottom, but one has cosine squared and one has 1 minus sine squared of t. Well, if we go back to that Pythagorean identity, sine squared plus cosine squared equals 1. If I subtract, right, if I have 1 minus sine squared, so if I subtract sine squared, I get cosine squared is equal to 1 minus sine squared. It's a common one that we use. Well, 1 minus sine squared is equal to cosine squared. So this is cosine squared over sine. And I have verified that those two are correct, or equal. Both sides of the equation are equal. So again, sometimes you have to work on both sides, and like I said, it happens more often than not when you have like 2 terms on one side and 1 term on the other. Sometimes you have to do that. Not always, but sometimes. And I just want you guys to know, like, okay, when I'm doing this, like, you know, I probably, when I was making this, did it the wrong way first and then had to go back and try it again. So don't get discouraged if you're working on one and you're just like, I have no, you know, like, I don't know where to go from here. Sometimes you have to start over and try a different method. So let's keep going. If at any point you guys want to try one of these on your own, and then pause the video at any point and try it, and then you can check your work when we go over it. Okay, so let's look here. I get another fraction. So I am going to see what I can do here. So I don't like this fraction very much. So I have cosine of x over 1 plus sine of x. And I want cosine on the bottom. So that means I'm probably going to want to get rid of this bottom, if that makes sense. So what you can do is you can multiply by the conjugate. And I'll show you what happens, why we want to do that. When we multiply by the conjugate, remember the conjugate is the same thing as the denominator, just 1 plus 1 minus, okay? So on top, I'm not going to actually multiply it out. Equals, sorry. I'm just going to say cosine of x times 1 minus sine of x. And then on the bottom, watch what happens when hopefully we remember what happens when we multiply conjugates, but I'll multiply it out just in case you don't remember. 1 times 1 is 1. 1 times negative sine is negative sine. 1 times sine is positive sine. And then sine times negative sine is negative sine squared. So negative sine and positive sine go away, and I just get 1 minus sine squared. Okay, so the bottom becomes 1 minus sine squared. Well, using our Pythagorean identity, 1 minus sine squared is cosine squared. So the top is still cosine x. Again, I'm not going to multiply it out. I don't want to make it more complicated. And then the bottom becomes cosine squared. When I have 1 cosine on top and 2 cosines on bottom, right? So they can cancel. And that leaves me, keep forgetting the equals, 1 minus sine of x over cosine of x. Oh, and that's what we wanted. I didn't even realize, honestly. Over cosine of x. And I verified that those two sides of the equal sign are the same. Okay. All right. I'm going to start getting into some more legit stuff here. Getting harder by the second. All right. Okay, so here I have two fractions added together and it becomes one term. So I'm probably going to want to combine these two fractions and get like a common denominator, if that makes sense. So let's start by maybe multiplying by the conjugate of the bottom since it's two terms and seeing where that gets us. So tangent of x over 1 plus secant of x. I'm going to multiply by the conjugate, so 1 minus secant x. Okay. And then I still have the plus 1 plus secant x over tangent of x. And I shouldn't write so big because I know this one's long. Okay. I'm not going to actually multiply this out. I'm just going to leave it together. So tangent of x times 1 minus secant of x. So remember, when you multiply by conjugates, the 1's square, and then it's minus the secant's squared. And then I have plus, 1 secant of x over tangent of x. Okay, 1 minus secant squared, again, if we're using our Pythagorean identity, first of all, you cannot cancel it with this. I know it's very, very, very tempting. You can't do it because this is secant squared and this is not. Okay? If it was, don't write this because it's not right. But if it was this, then you could cancel one of them. But it's not the whole term being squared. It's just the secant. And so it cannot cancel. Okay? But using my Pythagorean identities, 1 minus secant squared of x is tangent squared. So I can have tangent of x, 1 minus secant over tangent squared. And then I still have this 1 plus secant x over tangent x. So then one of these guys can now cancel. So I'm left with 1 minus secant x over tangent x plus 1 plus secant x over tangent x. Okay, I'm running out of room, so let's go here. Okay, so now I have a common denominator, so I can add these two fractions together, which is super awesome. Okay, I have, oh, sorry, this is negative tangent squared. I'm sorry. I'm like, why is this not working? That is negative tangent squared. Then I'm going to take the negative and put it up top. Whoosh, like that doesn't make sense. So negative 1 plus secant of x plus 1 plus secant of x all over tangent of x. That was my bad. 1 minus secant squared of x is equal to negative tangent squared of x. See, even I mess up, you guys. So 1 and negative 1 cancel. I have secant plus secant, which is 2 secant over tangent. So now, good news, I've gotten it to one term. So that's exciting. Now I'm going to go ahead and write these next to each other and maybe divide. So I have 2 over cosine, because that secant is 1 over cosine, right? Divided by tangent. Well, tangent is sine over cosine. Copy dot flip, so 2 over cosine times cosine over sine, right? So here I have a cosine on top and bottom, so those can cancel. And I'm left with 2 over sine of x. Well, if sine of x is on the bottom, that's the same thing as 2 over, oh, sorry, not 2 over. Oh, that's the same thing as 2 cosecant of x, which is what I was trying to find. Holy moly, that was a lot, right? That one's a long one. But again, just focus on trying to get common denominators and combine those, because you know you're going to have to get it to one term. That's a very, very difficult one, just for reference, so you guys know. Okay, we have 2 more here. And remember, at any point, if you want to try it yourself, just pause the video and try it, and then hit play, and we'll be doing it. So, okay, so here I have secants and tangents and a cosecant. It's probably going to be easier for me to get everything in terms of sine and cosine. So let's try it. So 1 over cosine theta minus tangent is sine over cosine. Cosecant is 1 over sine. And then plus 1. I don't really like the plus 1, so I'm going to write this as the 1 is sine over sine, right? Because that's 1. But just because now I have a common denominator, and that seems to be what I'm going to want. Okay, so I can subtract here. I have 1 minus sine theta over cosine times 1 plus sine of theta over sine. And do we remember how we multiply fractions? Right, the answer is straight across. So here I have conjugates, 1 minus sine, 1 plus sine. So that multiplies to 1 minus sine squared. And then I have cosine, sine. And then 1 minus sine squared should look familiar. That comes from Pythagorean's theorem. So 1 minus sine squared is cosine squared. Cosine, sine. So one of these cosines can cancel out, which leaves me with cosine, which I need to write smaller, over sine, which is cotangent, which is what I was trying to show. So I did it. We did it. Woohoo! Cool, kind of making sense. And again, a lot of these, sometimes I just sit and think about it for like a long time before I even start. Sometimes I have to start over. There's always something, okay? Okay, last one. 2 minus cosecant squared of z equals 1 minus cotangent squared of z. So again, I don't like this cosecant, and I have an identity that says that cosecant squared is equal to 1 plus cotangent squared, which is awesome because I know I'm going to want a cotangent squared in my answer, right? So I distribute, I have 2 minus 1 minus cotangent squared. 2 minus 1 is 1. and I'm right there. That one was a little bit on the easier side. Just recognizing that cosecant squared is equal to 1 plus cotangent squared. And that is one of the ones that we found by dividing, we divided by sine squared, like, right? We took the Pythagorean theorem and we divided by sine squared. Whew. Okay, that is it for 5.1 and 5.2. It's just practicing these, making sure you feel good about it. Please, 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 please reach out if you need any help or have questions or get stuck or like, I tried this one 6 times, I can't figure out, the right way to do it. Stuff like that. So let me know what you need, and we'll see you next time.